Welcome, everybody. Yes, to the first OpenShift Commons Validated Pattern SIG in February. We're going to be doing something a little bit different, just so you're all aware. We're changing our cadence to be the first Tuesday. Well, the first opportunity we have, because we're every other week, and you never know what months have 3, 4, or 5 weeks. The first one will be, yeah.
Last year was it.
You're making me think on this Tuesday. I appreciate it. We're going to have a general meeting on the first one of the month, and then the second one we're going to do open office hours so that we could talk through issues if people are having questions, how to deal with specific types of patterns, or how to deploy things, or if they're having concerns or questions about anything, we'll kind of go through those in a general sense. But today, I want to introduce Matt and discuss Veeam Kasten and how we've talked through or worked through a specific pattern. So Matt, please take it away.
Awesome. Thanks, Ant. Hi, everybody, and those of you watching recordings at home. My name is Matt Bader. I am a solution architect with Veeam that works on the Kasten product team. And just here to give a bit of a background, for those that aren't familiar on Kasten and data protection writ large within Kubernetes, and then get into how that applies to the validated pattern framework. So without further ado, we'll go ahead and share the correct screen. Awesome. And you can see that automating cloud native, so on and so forth. Title
it looks
slide.
Great. Yes.
Beautiful. All right, good. So we'll jump right in. Like I said, I'll give just a little bit of background on what's a Kasten. What is Veeam Kasten? How's it used? We'll talk about some need to knows relevant to data protection for OpenShift virtualization, and then I really want to jump right into how I came into working in the validated pattern framework and what we've done with Kasten so far. We'll show off a little bit of that in a live environment. I'll come back to some of the things that I would like to continue to build on this with. But certainly if there are other questions or even suggestions of, hey, have you considered doing X with your pattern, should have time for that too. So who is Veeam Kasten? Veeam Kasten is the leader in Kubernetes data protection hard stop. That probably begs the question for a lot of you of why do I care about data protection in Kubernetes in general? I'll give you the marketing spin on this. Not spin, but they do their jobs. From a stats perspective, like this is still a big gray area for a lot of the prospects and customers that we work with on a regular basis. Folks that are going through digital transformation of their teams, who is responsible for what, and I still see a lot of indications that, oh, hey, I can use my traditional sort of virtualization focused data protection tools to protect these workloads. That's not going to work out great for you. Or I just need to back up etcd. There's some great there's a great Ask an OpenShift admin episode from a few months ago on that exact topic and the constant failings of then trying to restore that etcd backup. And why do we need to protect these things in general? Certainly it's dealing with the rollbacks and accidental deletions, things of that nature. But the Kubernetes itself is not immune to the ransomware boogeyman that haunts all of us. Above and beyond that, it's not just about the protection aspect. It's also about mobility between platforms. So one of the great things about OpenShift, right, is I can run it on-prem, I can run it in AWS and Azure and so on and so forth. If I want to then move some stateful application from one of those locations to another, really need a purpose-built tool to accomplish that. And moreover, I need something that's going to be easy to adopt, easy to use. So marketing take on that. What's Matt's sort of practical take on why you need backup in Kubernetes. So, all of our applications are stateless. Well, no, a stateless application doesn't exist, right? You might have stateless components within Kubernetes, and then you've got some other backing database elsewhere. That's fine. That's still a stateful application. But even just those fully stateless components, right? I'm managing everything with OpenShift GitOps or Flux or something else. Who among us hasn't made some change under duress in production that maybe did not follow the process with which those changes are rolled out, right? Your source of truth, your Git repositories, it's not 100% guaranteed to be reflective of the deployed environment, right? You're ultimately in Kubernetes, your deployed environment is that source of truth. So that's certainly one reason. Just the growth of adoption of stateful workloads in general, running databases on Kubernetes, Postgres, MongoDB, MariaDB, et cetera, is becoming increasingly commonplace. So again, I'm consuming persistent volume-based storage on that cluster. Probably want to protect what's stored in those volumes. And then, one of the most interesting topics in that space, in stateful workloads on Kubernetes, is a big part of what I want to talk about today, and that's the KubeVirt project in general, or what Red Hat has built into OpenShift Virtualization. VMs are an inherently stateful workload, right, and require protection. So yeah, again, sort of differences between Kubernetes to sort of legacy virtualization environments. I probably don't need to spell that out for this audience in terms of backups that would have been very infrastructure centric versus things now that are very application centric. How I protect Helm charts and operators and custom resources for one application could be very different from another application on my cluster, right? But the thing that again kind of brings these two worlds together for Veeam Kasten is this idea of running virtual machines on Kubernetes. So KubeVirt powered VMs. And Red Hat has done a lot in this space to make the adoption of OpenShift virtualization much easier. I probably don't need to get into the reasons why people in 2024 and 2025 are considering alternate hypervisors. But there's a lot of interesting work here going on with the migration toolkit, and working with different services partners to make that a very seamless end-to-end experience for customers. And Veeam Kasten plays an important role in this, in that it's not just about how do I move these VMs from hypervisor A to OpenShift virtualization, but that gap that we're looking to fill there is how do I ensure the ongoing protection, whether it's just from a backup and restore perspective or a disaster recovery perspective for those Kubernetes-based VMs. And that's exactly where Kasten comes into play. So again, I'll try and go through value prop in as much of a single slide as I can of why Kasten. So a big piece of this, what we'll get into with the integration into the validated pattern, is being a Kubernetes-native solution. That is to say that Kasten is just another application that runs on your OpenShift cluster, and is responsible for orchestrating communication between the API server and your underlying storage. Maybe that's the OpenShift Data Foundation CSI, or directly in AWS you're using the EBS CSI. So communicating with both the API server and underlying storage to snapshot workloads, and then ultimately being able to export that data because snapshots are not backup. I want to be able to export all of that data from that point in time to, whether it's a Ceph object gateway in S3, or I'm sending it to Azure Blob or VBR or in NFS share. So providing a lot of choice is obviously an important consideration here too. When you can run OpenShift in so many different environments that can consume so many different types of primary storage. Having that broad ecosystem, I think, is another value that isn't necessarily reflected here. We'll see when we get into the demo. Ease of use is very important to us. How do I, especially for those that aren't very experienced in Kubernetes, how do I make it easy for those administrators that are responsible maybe for data protection for a vSphere environment? How can that person then easily adopt a solution in Veeam Kasten? We talked about the ransomware boogeyman. So being able to support, the creation of immutable backups when we're exporting all of that data is critical. Blueprints and transforms, we won't talk about too much in this session, but blueprints is basically a framework that allows us to quiesce different types of workloads, or even perform logical backups of certain workloads where maybe a storage snapshot based backup is just not something that a given data service might support, right? If I've got like a distributed database, etcd is actually a good example of one of those, where if I can't get a consistency group of snapshots across multiple pods, multiple PVCs at the same time, I really need to do some kind of logical backup of that workload. Transforms is another framework in the product that allows us at the time of restore to change things about a given backup. So let's say I'm going from OpenShift running on-prem to OpenShift running in AWS. And all of my storage class names are going to be different from my source to my destination. That's a pretty quintessential example, but it could be, updating the host value of a route as I'm moving from cluster to cluster. So the ability to have this robust ability to add or remove or change manifest data as part of that restore operation is very critical. And I think one of the biggest things here is just velocity itself. You've got many other solutions in this space that are tied to kind of legacy virtualization or bare metal focused backup solutions that release twice a year. Kubernetes itself releases 3 times a year, and many other things in this space again move very quickly. So releasing a new version of Veeam Kasten every 2 weeks just it gives our customers an opportunity to not be held back on adopting some new version of Kubernetes because they're waiting for their data protection solution to support this. So as much as I can kind of cram into a single slide, and then a couple of the other, I would say the most common question I get once people start to understand, okay, yeah, I do need to back up certain workloads in Kubernetes, but aren't there free options for this? Can I use OADP in OpenShift, which is based on Valero? And I won't spend too much time digging into that too, but just a little bit of food for thought on that topic. The call it the operationalization or productization of implementing a Valero-based solution in a customer environment. The adoption curve when you don't have a UI, when there is no sort of built-in monitoring and reporting, who's responsible for supporting this thing is kind of that classic build versus buy consideration. But I would say some of the other big capability gaps that I try and point out for people is, again, not having support for the ability to create immutable backups to me is absolutely critical. If someone gains access to your S3 bucket that you're exporting all of these backups to and can wipe out all of those, that's not a very effective backup. Similarly, that same attack vector, I've gained access to that S3 bucket where all of these are being exported to. Valero and by extension OADP use a common, well-known key for encryption of all of that data across every install and every cluster ever. Kasten has per policy and per namespace generated encryption keys that, again, you can manage a sort of the primary encryption key through the product or through external KMS solutions. So being able to strengthen the integrity of those backups, making sure that if someone gains access to that bucket, they don't then have access to all of your data is a very big deal. And then the other common thing I see in larger customer environments is, the autonomy that Kubernetes can provide of making, namespace owners, giving them the capability to perform different tasks. A Valero-based solution is very much all or nothing in terms of the permissions it requires to operate on the cluster. You either effectively have cluster admin privileges or you have nothing. From a Kasten perspective, I can easily carve that out to provide some secure self-service to end users where, they can create their own backup policies for namespaces A, B, and C and can restore into those namespaces, but can't leverage, Kasten service account permissions to do things in other spots. So just again, a little bit of introductory food for thought of why going the buy route versus the build route really does matter when you're talking about something that is ultimately your last line of defense of recovering your corporate data if the worst thing happens. All right, so considerations specific to OpenShift virtualization. One of the big ones I like to call out here is the preferred format for using a PVCs for KubeVirt-based VMs is a block based a raw block based volume as opposed to a file system volume, which would be the default in Kubernetes. Just gets mounted as a mount point into a pod. This is attaching raw block storage to that pod. This obviously has advantages when we're talking about virtualization in that my guest VM is going to have its own file system that it's writing into that volume. So I'm eliminating layers of file systems there. I'm eliminating capacity losses I would see with having, multiple stacked file systems. But the big thing here is for many SAN storage platforms and including AWS EBS, is I can still get read-write many access mode with block-based storage. So I don't need an NFS or NAS-based solution to deliver read-write many access mode for these VMs. Why do I care about read-write many access mode? Is live migration, or what our former vSphere administrator friends would think of as vMotion, right? I need to be able to migrate VMs between nodes so I can do rolling upgrades without having to take down virtual machines, right? We've been doing this since 2006. It was like the original killer feature for virtualization, but requires this shared storage access to be able to do that handoff between nodes. So if I'm doing a block-based volume for my VMs, I need a data protection solution that can back up those block mode volumes. And that's something that we'll add that to the OADP/Valero list, that those solutions can create local snapshots of a block-based volume today. It can't export that data. So again, snapshots are not backups. I need to be able to export that data. This is something that Kasten does natively, can even still create incremental backups based off of these block-based snapshots. And this is an area where we're really trying to drive some industry-wide innovation here as well. There is no standard for change block tracking in Kubernetes today, in the same way that we have sort of standardized APIs for volume snapshots now. So this is something that's being driven by Kasten engineering. We're very interested in working with storage partners that have change block tracking capabilities within storage today, but just, again, don't have a standardized way to expose that through the CSI provisioner. So block mode, important to the OpenShift virtualization use case, important for how do I, again, back that up. And I guess just before I hop into, our the validated pattern example that I've worked on in the demo, who else is doing this? OpenShift virtualization is still relatively new. I mean, we are seeing this being deployed in environments that I would have historically thought of as being, customers that are very averse to change or very averse to leading on the bleeding edge. Are this specific case study with the U.S. Navy is deploying OpenShift virtualization on ships, at the fore and aft of naval ships, with Kasten being able to protect those VMs in the cluster in the front of the ship, and send it off to that cluster in the back of the ship, and then when there is connectivity, be able to export that data also off of the ship. So pretty cool use case there. Okay, so in that case, then we'll jump into the next part. I promise I'm just about out of slides at this point. Again, for this audience, probably don't have to recap the why behind the validated pattern framework. This is something I've become sort of a zealous believer in. But yeah, let's. So how did this come about for me in particular? This was, it was Michael St. John that made me aware of this project in the first place. Said, hey, this is something you should really check out, because he knew I was really interested in developing other just sort of generic GitOps solutions for deploying and managing Kasten. And there's a lot of flavors. There's a lot of flavors out there, and I'm there's a lot of value to me in having the validated pattern framework actually being an opinionated stack. But this was kind of what it looked like for me, was attempting to deploy an existing pattern without just reading anything at all, just trying it. Definitely not reaching out to anyone for help when it didn't go right the first time. Probably getting frustrated or asked to work on something else, had a squirrel moment, and completely abandoned working on this for a long period of time. Came back to this shortly before the last OpenShift Commons, spent a couple hours just reading the actual documentation and the really great validated pattern workshop published docs through the website as well. Had a couple of follow-up questions that I was able to ask of folks that I got connected to through this SIG group in the office hour calls, and within that same afternoon was able to go from not being able to deploy my first pattern to having extended and sort of met my initial goal. So certainly I think my lessons learned in that for anyone else watching this recording that hasn't started working on their own validated patterns yet, is don't do what I did. Absolutely take advantage of some of these really great resources on the website. Take advantage of the Slack channel, of office hours. I've even seen activity on the validated patterns GitHub in the issues tab, and you can really kind of accelerate getting to that last step. So where this is a bit of an eye chart, but this is the original sort of schematic for what was called the Ansible Edge GitOps pattern, which is, or at least at the time, was the only pattern that made use of OpenShift virtualization, which is what I was sort of my initial target around the around my interest for validated patterns, and specifically, so going back to that U.S. Navy case, which is very much an edge deployment use case. The idea here being, hey, I need something that is highly automated, where I can drop gear into place and know that consistently it's going to be staged with all of these things that I need and done in a very declarative way. So great, there was this out-of-box pattern for doing the deployment of OpenShift virtualization, for deploying AAP to then do some imperative-based staging against those VMs. But again, the one thing that this was missing is there's no means for protecting these VMs out of the box. So how do I integrate, Veeam Kasten ultimately into this existing pattern with some best practices in mind to provide that one-click kind of experience that people with this particular use case, or again, extending the same ideas to other patterns, would be able to really integrate Kubernetes-native data protection out of the box. So I'm going to jump into VS Code and a demo environment here, but just because all of this is probably going to blur together for folks at a high level, these were the different areas that I added to the existing pattern. Was first to handle the deployment of Kasten by adding an additional operator subscription. The Kasten operator is essentially a Helm wrapper style operator. So deploying then the instance of Kasten as an operand and setting up some basic access configuration to Kasten itself. So creating a route, configuring authentication. And then once we've deployed, I've got all of my CRDs in place, I can start doing some post-installation configuration of that Kasten instance. So the big ticket items here is configuring, hey, where are we going to back up this data to? So in this case, in S3 bucket, these are what we call location profiles. Configuring the Kasten DR policy. So I'll talk a little bit more about what that is when we get into the demo environment. And then leveraging the external secrets operator integrate and Vault integration within the validated pattern framework, taking advantage of that so I can create my external secrets resources specifically for what I would need for this Kasten DR policy and my location profile. And that to me, honestly, was the aha moment of things I've struggled with in other environments of secrets management in the GitOps paradigm overall. It's like the good news is you have options. The bad news is you have options. I really like, again, this opinionated middle ground of Vault with now some flexibility to support other backends, but sort of standardizing somewhat on using the external secrets operator to consume and produce those secrets on the cluster. I'm a very big fan of. And then we've got some other, again, just other Kasten configuration we'll look at in VS Code. And then the last piece of this is what we wanted out of this in the first place, which is I want to make sure that as I'm creating deployments of virtual machines on that cluster, that again, those are going to be protected out of the box. So with that said, let me swap over to here, and it looks like I can see my screen. Yes. All right. So how are we doing on time? We're about halfway through. Great. So every pattern, right, kind of starts with the values global and the values of whatever your named cluster groups are. So in this case, the hub cluster group. Hub in this context might be a bit of a misnomer, as the goal of this pattern really is standalone edge deployments. So this is different, I guess, than the multi-cluster GitOps pattern, where you do have much more of an actual hub and spoke model. But so this was, my entry point for adding Kasten, which again, had I started with the documentation as opposed to just reading through all of this and trying to figure out how it worked, would have saved myself quite a bit of time. But yeah, so quite straightforward. We're just, all right, I need to add another namespace. Because I'm deploying from the operator, I need to add another operator subscription for Veeam Kasten. So we've got the operator is present in the Red Hat marketplace. There actually are a few different flavors of this depending on whether or not you're transacting through the marketplace. So that might need to get tweaked in a real world deployment. This points to the free version of the operator. We're doing automatic approval for the install plan for the operator. This is one thing that I plan on hopefully coming back to office hours soon to discuss a bit more of best practices. For I've not actually seen examples in the wild of people using a manual install plan through the validated pattern. So a conversation I'm really interested in having with folks. We're not taking advantage of any of or rather adding any new imperative jobs through Ansible. So we don't care about anything there. But what I do care about is based on my, I've got my operand now, or sorry, my operator added now, but we also need to spell out what are the applications that are going to be created and managed in OpenShift GitOps in Argo CD. So we can see all of the defaults that were associated with this pattern, and our edge GitOps VMs, which is defining a namespace that's provisioning multiple different VMs. And then my big additions here would be Veeam Kasten, which is the deployment of Kasten itself, and then the post-installation configuration. So again, just pointers to the application definitions in our charts folder. So if we jump into those, so again, we'll start with Veeam Kasten, the deployment itself. Actually, let me take that back. So in addition to values hub, I did start extracting certain configuration details into a top level values file specific to Kasten, with the idea of kind of abstracting certain things that could be deployed or could be set really on a per cluster basis, rather than things that might change on a per implementation basis that I might want to specify within these examples. My goal for a lot of these was to make them as generic as possible to make it easier for other users to adopt. So if I look at then my top level configuration, so leaning into the built-in Vault instance, enabling this Kasten DR policy, actually I need to create a passphrase for encrypting this one particular backup. Again, I'll get into why that is. But all right, where does that live in Vault? Could have just hard coded this, but helpful I think to have it exposed. For creating a new policy, do we want to define if I've got multiple location profiles? Do I want to set one of these things as a default? So again, just eliminating things that an end user, an application owner that is ultimately, not a Kubernetes data protection administrator, how do I abstract away as many things as possible for them to define a policy? Defining a policy for them should be as easy as maybe picking a preset and then pointing to a namespace of this is what I want to back up. So this is just, in furtherance of that goal. And then built another, actually based on some neat work that I saw Martin do for creating the VMs, rather than have location profiles, so that backup target be completely manually defined as just a one-off manifest to live in one of these application definitions. How do I just abstract that into a loop where you can put just declarative details of what I would care about for that location profile into this top level configuration, and then ultimately have here, so we can see we've defined one. We'll go and do a test update later. But with that location profiles, have it just iterate over that entire range from the Kasten values file. So again, just making it easier for an admin to create additional location profiles without, again, just having one hard-coded additional manifest that would land in that directory. There's certainly nothing wrong with doing that. And again, if you're maintaining a couple of generally one location profile for a cluster, this might be overkill. But I think it is sort of a fun exercise in looking at, what best practices could ultimately look like for off-the-shelf consumption of a validated pattern. So again, yeah, that's everything that's described in that top level file. So if I jump up into the Veeam Kasten, so this is again just deploying the operator itself. The operand itself. So the one thing I've done here that I already hate and need to change is it's setting the EULA information. Like, these are things that, again, that would only be done once per cluster. This should be relocated to that top level file. But then the things that are configuring our Kasten deployment, so that operand, this to me reflects a bit more of a best practices style deployment, where we are configuring, accepting the EULA, great, kind of basic, but most importantly, enabling external access. So creating a route automatically at install time, and then also integrating with some form of authentication. So in Kasten, you could do LDAP, you can integrate with IAM, or just use Kubernetes bearer tokens. But we've also got direct integration with the OpenShift OAuth server. So for this use case, it makes perfect sense where I would want to do that. And again, leveraging some of these global values that I'm getting from my stacked validated patterns values files here makes it really easy to dynamically configure this, so I don't have to, again, hard code examples from cluster A to cluster B to cluster C. And then the only other change that I'm doing in here is I've got this list of excluded apps. So by default, Kasten is going to discover all of the namespaces in the entire cluster. There are a number of these sort of system namespaces specific to OpenShift that I'm never really going to be using Kasten to protect any of that. That's just part of the declarative state of provisioning my OpenShift cluster really in the first place. So I can hide all of these from my user interface. That's the only purpose of having those in there. And then the post config chart. So again, the chart description itself is just pointing to our templates file. But what are we actually doing in here? Again, this can probably just get pulled from global values, but left it in case, hey, I want to separate out my Kasten specific secrets. If I want to create a separate cluster secret store resource to authenticate for those, if I want to start implementing some RBAC on the Vault side, you've at least got a pointer to start carving that out here. Again, where do I find this passphrase that I need for my Kasten DR policy? And then this is just a container image that I can run OC commands. And we'll tackle that one last. So we looked at location profiles. Again, this is the really, to me, one of the benefits of Kasten is that everything is a Kubernetes native resource. So this location profile, again, is just a custom resource. So it makes it very easy to, again, create these things declaratively through things like the validated pattern framework, versus if I'm trying to integrate with some legacy external virtualization focused data protection platform that, yeah, maybe it's got REST APIs that point to some of these things, but again, maintaining that declaratively through a framework like this, it's not something that I would wish on anyone. So my profile in this particular case, I haven't abstracted this fully today to support all of the different location profile types that Kasten can work with. So that I've got kind of flagged as future work. But otherwise, taking advantage of those stacked values files and just being able to dynamically populate some of these figures here, like protection period, for instance, is when I'm creating a location profile that supports immutability. How long do I want that immutability period to last? My Kasten DR policy. So again, this is just another Kasten specific custom resource. Kasten DR is something people often get confused about. It's because we are an application that runs on the Kubernetes cluster itself. We are a stateful application. We have our own backend database with PVC tied to it. We've got other PVCs that maintain logging history and some other things within the product itself. So Kasten DR is basically the backup policy for Kasten itself. So this is, from a best practices perspective, this is something that I would need to turn on, right, in a normal manual deployment. The advantage of having a fully automated deployment here is I know right out of the gate that I've got something that is not just going to protect my applications, but also protect, my catalog of restore points itself. So we've got that integrated out of the box. As I mentioned before, taking advantage of the external secrets operator and Vault to make sure we're securely configuring these different resources. And then the other fun thing that I added in here was Kasten from a storage perspective. We have a couple of requirements in that if we're working with a CSI that does volume snapshots, we need to place an annotation on that volume snapshot controller that says, hey, Kasten, this is the right volume snapshot class for this particular provisioner. This is something where, again, depending on a customer environment, they might have their volume snapshot classes defined as an application being rolled out as a part of that validated pattern. But there are instances where installing a storage platform itself is going to create some default storage classes. It will create a default volume snapshot class, as is the case with deploying ODF, OpenShift Data Foundations, that I can't customize that at the time of deployment. So what I've done here is create kind of a post-sync job that will look for those kind of well-known storage class or volume snapshot class names and say, okay, yeah, these are the defaults. If if we haven't already applied the Kasten specific annotation to those, just go ahead and do it. So every time I make a change to this repo, it's going to run this very quick job just to make sure those annotations still exist. And that's basically it, with the exception of this one I added literally right before the webinar, because as I jump over to my browser, so we could actually see some of this stuff. Great, so we are in, so yeah, we're in that OpenShift console instance. The first thing I would always do is jump to networking and routes and search for the K10 route to go open up my dashboard, until I realized, I'm like, oh, hey, everything else that's exposed in this pattern uses these console link manifests to expose these nice friendly links out here. So we just pushed one of those into the repo too. So we can see here, actually, if I jump to, my hub Argo CD, so this was, again, all of those applications defined in our pattern, including our synced Veeam Kasten. So if I squash this down, again, the only sort of managed resource here is that K10 operand. Everything looks good there. And then my config resource, so we can see, those from previous syncs, those will ultimately get cleaned up, but the jobs for running the annotations and all of my other individual sort of post install configuration. So my external secrets, which become my secrets, which then get pumped into my location profile or my DR policy. So everything there looks good. If I then so take advantage of my fun new link here. So this was what I mentioned before, being able to directly integrate with OpenShift OAuth. Rather, you could directly integrate with your OIDC or LDAP directly to the Kasten dashboard. One thing I like about using the OpenShift OAuth integration is, again, then I know as I'm moving from one console to the other, I am this user. Or if I'm already logged in, then that becomes an even more seamless experience. Or certainly if you've got multiple IDPs that are integrated into a single OpenShift cluster, then absolutely taking advantage of that is helpful. All right. So now that we're in the Kasten dashboard, again, we can see that Kasten DR has already been set up for me. If I look under location profiles, this has already been configured based on what we laid out in that values file. And oh gosh, the most important thing that we skipped over here was in our Edge GitOps VMs, right? This was the part of the policy that's responsible for creating the virtual machine resources themselves within that cluster. So this is where, again, I think it does make sense that the policy for that application should live with your CD resources for that application. It doesn't make sense for this to live in Veeam Kasten config. It should live, again, right alongside that particular app. So again, we are taking advantage of some of those other defaults that we've set, or whether or not this is going to use an available preset, what namespace we're applying to. So it is a very generic policy that could then be extended to, if I created additional applications, additional namespaces to provision VMs in, would be really easy to use this exact same policy then for each of those. So they, again, don't need to be hard-coded, don't need to be unique for each of them. But if I look at how that's manifested now in the UI, so again, I've got my Kasten DR policy, and then I've got my Edge GitOps VMs backup policy. So very reflective of what we saw in that configuration, or maybe the better way here, if we look at, okay, great, it's using this daily backup policy preset, and we're protecting the Edge GitOps VMs namespace. So from the time that I did the pattern make install and it started laying all of this out, have not touched this environment since. And we can see that the KDR policy is running hourly as expected. And then I believe the my VMs policy I've only got set to run daily here. So we can see where that ran at 5 p.m. yesterday, created the initial snapshot, exported that data then to my defined S3 bucket. So from just pattern make install, I've now got not just my declaratively provisioned and staged virtual machines, but I'm also sure that any subsequent changes to those VMs is going to meet, you know, my SLA that I've defined for protecting them. And of course, then if we want to do a tiny demo on making some change here, so we had just one location profile before. I've got a second profile here pointed to a different bucket. Maybe these again are in different regions within AWS in this case. But we'll go ahead and define that, and we'll go ahead and say, all right, we're going to add this and update location profiles. Commit this to our repo. Push that to our repo. Wonderful. We'll come back to here and go ahead and refresh this so we're out of sync and it's syncing. We can already see, yep, my external secret for extra profile. And then under profiles, my extra profile. Wonderful. So if I go back to the Kasten UI, location profiles, and there it is. That easy. Didn't have to make a live one-off manual change to this environment, and everything is nicely buttoned up in my Git repo. So that's where I'm at today with this pattern. I've certainly got more that I think I'd like to do. As I mentioned, you know, improving that abstraction to support other types of location profiles. This is an obvious one. We're running Vault on these clusters, you know, by default with the validated pattern framework. I should probably be protecting that Vault instance out of the gate as well. But I think that the big one that I'd like to circle back to is using the multi-cluster GitOps pattern, extending that pattern to take advantage of Kasten's own multi-cluster management features, or even just from a visibility perspective. So that'll be kind of my next big step. And I won't. I think that the people that need this feedback have already gotten feedback on things I'd like to see change within the framework itself. But yeah, that's it. And certainly for those of you that haven't played with Kasten at all, if there's any interest on your part, free to download and use up to a cluster of 5 nodes that's, you know, fully featured. So definitely worth taking advantage of for those home lab environments too. That's it. Nice.
Sorry to be so quiet. It was interesting to watch that. I've never heard of this technology before. So I was kind of just a fly on the wall watching.
Yeah, all good. I mean, certainly if and for the people watching the recording too, you can find matt.bader at veeam.com. I don't know that you can find me on Twitter anymore. Smoke signals, I accept those, or just Matt Bader on GitHub too. Or, you know, I'm in the validated pattern SIG on Slack as well. So yeah, happy to engage with folks more on this. I'm definitely a fan and a believer in the framework now for sure. It's more like hours in the day are what keep me from tinkering on this further.
Thanks for putting this together, Matt. That was a great presentation.
Yeah, happy to participate. Thanks for having me, guys.